Exploring Squares, Part 2 by Jeff Simpson. In the Part 1 video, we used graph paper to draw a 2x2 square. You can get graph paper with larger squares. Here's what a 2x2 square looks like on graph paper that has 1-inch squares. 2 inches by 2 inches. You can get 1-inch graph paper online or make your own. If you cut out one of the squares from a piece of 1-inch graph paper and then measure it with a ruler, 1 inch, you can see that each side is 1 inch long. So we call this 1 square inch. If you draw a diagonal line from corner to corner and then rotate that line so that it lies flat, you can see that the diagonal is more than 1 inch long. Draw 6 2x2 squares on your graph paper. Notice each 2x2 square contains 1, 2, 3, 4 square inches. We're going to find 6 different ways to cut these squares in half. Go to the first square and draw a line down the middle to cut it in half. Color the left half of the square, which is 2 square inches. Now cut the second square in half by drawing a line across the middle. Color the bottom half of the square, which is also 2 square inches. Cut the third square in half by drawing a diagonal line starting at the upper left and color in the lower left half of the square. Question: is that colored section 2 square inches? Well, let's take a closer look. Yes, it is 2 square inches because there's a half plus a half, that makes 1, and 1 plus 1 is 2. Notice the bottom of the square is 2 inches wide, but the diagonal is more than 2 inches long. Cut the fourth square in half with a diagonal line starting at the upper right. Color in half of the square, and yes, it is 2 square inches. Draw 2 diagonal lines through the fifth square, starting at the upper left and at the upper right. Color 2 half squares on the top and 2 half squares on the bottom. This is also a total of 2 square inches. On the last square, draw diagonal lines through each square inch, connecting the midpoints of every side of the big square. Color 4 half squares in the middle. This is also 2 square inches. 2 square inches can look like this, or this, or this, or this, or this, or even this. The Part 1 video showed how you can combine 2 squares to make a bigger square. Here's an example. 3 squared, that's 3 by 3, and 4 squared, that's 4 by 4. Now watch what we do with the 3 squared. We're rearranging it, so now it's 5 across and 5 down. That's 5 squared. We've combined 3 squared plus 4 squared to create 5 squared. Is it possible to combine 1 square inch with another square inch to make a bigger square? Let's find out. If you move this square next to the other one, that makes a rectangle. Or above it, that makes a rectangle. Or below it, that makes a rectangle. Well, together they do not make a square shape. But if we cut each square in half with a diagonal, and then rearrange the pieces, we do have 2 square inches in the form of a square. There's 4 halves, that makes 2. So it is 2 square inches, and notice it is still a square even if it is rotated. If we put the original 2 1-inch squares corner to corner with the combined square, they make a right triangle. There's that red right triangle right in the middle. Let's compare the 2 square inches to the other squares that we already know about. We can see the 1 square inch is 1 inch wide. 2 of them are 2 inches wide. 4 square inches is also 2 inches wide. But if we rotate the 2 square inches, we can see that it is wider than 1 inch, but shorter than 2 inches. Question: can 2 square inches be combined with 2 more square inches to make 4 square inches? Good question. Let's find out. Yes, they can be rearranged to make 4 square inches. And in the space between them all is a right triangle. It has a 90-degree angle right there in the corner. Is it possible to combine 4 square inches with another 4 square inches to make 8 square inches? To do that, let's connect the corners with a diagonal line and then use that to make a new square with diagonal lines. Notice the space in between is a right triangle again. Now, can we predict that the new square will have exactly 8 square inches? Let's cut the smaller squares in half with diagonals and then rearrange the parts. Yes. Here's something else to notice. A 4 by 4 square has an area of 16 square inches. If we connect the midpoints of the sides, the big square in the middle, well, the big square is cut in half, leaving 8 square inches in the middle. And if we cut this square in half the same way, 4 square inches are left in the middle. And if we cut this square in half, it leaves 2 square inches in the middle. And if we cut this square in half, it leaves 1 square inch in the middle. With smaller graph paper, you could draw a square that is, let's say, 20 units across and 20 units down, which has an area of 400 square units. That's right, that's actually 400 in there. Half of 400, well, half of that is 200. And half of that is 100. Half of that is 50. Half of that is 25. Or you could draw a square that is 12 units across and 12 units down, which 12 by 12, that's an area of 144 square units. Half of that is 72. Half of that is 36. Half of that is 18. And half of that is 9. Or we could draw a square that is 8 units across and 8 units down. It has an area of 64, and half of that is 32. Half of that is 16. Half of that is 8. Half of that is 4. Getting smaller and smaller. Half of that is 2. And half of that is 1. Pictured here are most of the squares that we've just been considering. These squares have something in common. We know the side length or width of every square here. Look at this one. The width or the side length of the big square that contains 100 little square units must be 10 units because, well, 10 times 10 is 100. And 10 times 10 is the same as 10 squared. So how wide is the square that has an area of 100? Well, you could say the width of 100 is the square root of 100. And 10 is the same as the square root of 100, because the square root of 100 is 10. Let's take a look at this square. The square with an area of 64 must be 8 units wide, because 8 times 8 is 64. 8 times 8 is the same as 8 squared. And 8 is the same as the square root of 64. The width of a square with an area of 64 must be the square root of 64. The square root of 36 is 6. The square root of 25 is 5. The square root of 16 is 4. The square root of 9 is 3. The square root of 4 is 2. And the square root of 1 is, well, 1. Here you can see the square root, or width, of all of these squares. Here are some of the other squares that we've been considering. These are the squares that were made with diagonal lines. Here, let's rotate them so they're lying flat. What is the width of the square with an area of 72? Well, it must be the square root of 72. But what number times itself is 72? Could it be 8 times 9? Because 8 times 9 is 72. No, 8 times 9 is not a number times itself. And besides, 8 by 9 makes a rectangle, not a square. So it can't be that. So, square root of 72, could it be 8? Well, no, because 8 times 8 is 64. 8's too small. Maybe 9. 9 times 9, no, that's 81. That's too big. So the square root of 72 must be more than 8, but less than 9. So 8 point something. Let's take a closer look at this. The square that has 64 units inside, square units that is 8 units wide. The square that has 81 is 9 units wide. The square with an area of 72 is more than 8 units wide, but less than 9. So the square root of 72 is approximately 8.4, 8 4/10. Actually, a closer approximation of that is about 8.48528137423857, but we'll say square root of 72, close enough, was about 8.4, 8 4/10. Here are the approximate widths, or side lengths, in other words, the square roots, of the squares that were made from diagonal lines. The square root of 72 is about 8.4. Square root of 50 is about 7.1. Now, if you compare that to something else you know, the square root of 49, is 7, and that's pretty close. So 50 would have to be a little bit more. Square root of 32, about 5.6. Square root of 18, approximately 4.2. Square root of 8, about 2.8. Square root of 2, approximately 1.4. Now, get some graph paper and some scissors to investigate the side lengths of these unusual squares for yourself. Here's one example you can do. Draw diagonal lines that are, let's say, 6 diagonal units long to make a square that contains 72 square units. Cut out the square that you made with diagonal lines. Rotate the square and use the lines of the graph paper to measure its width. 72 square units, about 8.4 units wide. If you draw a square with 5 diagonal units on each side, the area will contain 50 square units. 4 diagonal units on each side makes an area of 32 square units. 3 diagonal units on each side makes 18 squares inside. 2 diagonal units makes 8 square units inside. And 1 diagonal unit on each side makes 2 square units inside. There are even more creative ways to use diagonals to create squares and combine them, but this is enough for now. So that's all for the Part 2 video. Thanks for watching. Please share these ideas with other people who can benefit from them.